Okay, for this rather long combined spec question, here we've got a little bit of mass data, a volume, and an infrared spec graph, and asks us to find a few bunch of unknown chemicals. So the first thing to do is go through the question and look at what we've been given. Not just what we've been given, but what it's about as well. So not just 4.77 grams, 4.77 grams of copper oxide, 3.81 grams of solid E, and then we have a mass and a volume of gas G. And then it's worth realising as well that this infrared spectrum is about chemical I. So using the moles data, where whenever you're given the mass of a known chemical, you can always find the moles. So that for me would be always just the first thing I do. We're giving the mass of a known chemical, let's just find its moles. So we're going to do moles equals mass over mR to give us this number of moles here. Now, assuming that the copper oxide to solid E is a 1-to-1 ratio, that means we also know the moles of chemical E. You're told the mass of chemical E, so we can rearrange and say mR is mass over moles, feed in the mass from the question. You already found out the moles here, and that will give you the mR. You then look that up on the periodic table, and believe it or not, it's copper. Now, that should have been pretty obvious that's going to be the solid from the question, but we know now because we've got the mR. So we now know the identity of E. Kind of separately, but also using molesy stuff, we can find the identity of G. And so we're told the volume of the gas at room temperature and pressure. Now, as it's room temperature and pressure, we can use the equation moles equals volume of a gas over 24. If it wasn't at room temperature pressure, we'd need to use PV equals nRT, so we'd need a lot more data. But it is, so we can. So convert this into decimeters cubed by dividing by 1,000, and then divide by 24 to get your moles of G. Just like we then did with E, we can say the mR of G is mass over moles. You're told the mass in the question, divide by the moles to get the mR, and then just use a little bit of common sense then. So what gas could equal 24? There's only a few in there. It could be O2. So that's probably the first one I'd check. Does O2 add up to 28? Well, no. And maybe CH4, that's a common gas. Does that add up to 28? No. N2 does, doesn't it? Most of the atmosphere is made out of nitrogen, so it's definitely a gas. So we now know the identity of G. Moving on, just bear with me a second. So moving on, we can look onto our infrared spec and get that data sheet out, and also look at the molecular formula. This is a big clue because this tells you what elements you've got to play around with. There's an oxygen there, so this bond here is going to be a C-double-O bond, isn't it? They occur between about 1,700, 1,800. So at about 1,700, we have a C-double-O bond. And I know I should expect that because I've got an oxygen there. It could have also been an OH, maybe. But I've got a deep peak, about 1,700. That's going to be the C-double-O. I've also got a fairly broad peak here. There's actually two. Now, this could be caused by an OH, perhaps, because they occur around that spot, maybe a little bit less. But we've already used our one oxygen here. And look, our molecule only has one oxygen. So if this is the C-double-O, if this is the C-double-O, this cannot also be an OH, because that would mean you'd need two oxygens, and we've only got one. So can you see how using this molecular formula is really useful to help you deal with this? We do, however, have a nitrogen, and if you look on your data sheet, second to bottom, you'll see that the NH is also round about this region. And we see we've got a peak there. So this is going to be an NH, and what's that? Something like 3,200, 3,300, something like that. If you want to just write down the range from the data sheet, that's totally fine. Now, can you see actually there's two peaks at almost the same spot? So we've actually got an NH2. This sharp peak here, this is just going to be a CH, but we don't really care about that because everything's got a CH. That doesn't help us in any way, so I'm just going to ignore it. So again, bearing in mind our formula, now we know it has these bonds here. What I would suggest it is this molecule here, a primary amide. So this is going to be I. Now I would have lost a mark for saying that this is I if this was an actual exam paper. Just have a little think, why might I have lost the mark? It's because I didn't put my H's on. You gotta start putting your H's on in exams, yeah? Okay, so we now know what I is. We are also asked to give some equations. If I scroll down, write equations for the two reactions. So I'm kind of running out of space, bear with me here. There we go. So for the first equation, we know we started with our copper oxide because it told us in the question. And where it said in the question that it was reacted with ammonia. So we can slowly build up this equation. We know that chemical E was copper. We calculated that using all the mass data. And we know that chemical G was nitrogen. Again, we calculated that using the volume and the mass data. Now, we're also said that there is a liquid F. So we know it's a liquid, the question said so. And if we look at the atoms we have on the left and the atoms we have on the right, can you see we haven't used up any of the hydrogens or oxygens? Now, I guess it could be many things, but if you had to guess what is a liquid that contains hydrogens and oxygens, it's going to be water in it. And so the third product, liquid F, is water. We then just need to balance it, so you're going to end up with a 3, a 2, a 3, and a 3, just to make it all nice and balanced. Moving on to the second equation, well, again, let's just build it up slowly. We know that chemical H was reacted with ammonia, and we know that the product of that, chemical I, we got this from the infrared spec, was our primary amide. And the question also tells us we had a chloride salt. So I'm thinking, right, is this going to be an organic equation? So because I've learnt all my, so let me get all this in here. Because I've learnt all my organic equations, I know that something plus an amine to give me an amide and a chloride salt, well, it's going to be an acyl chloride, isn't it? So H is going to be an acyl chloride, because I know acyl chloride plus ammonia goes to amide. So this is where those organic equations really come in. And so what's happening here is the Cl is removed from the acyl chloride, so that'll give me a Cl in the bank. A H is removed from the ammonia, that gives me a H in the bank. And then the NH2 attaches to that carbon to make my amide. But the question didn't say we ended up with HCl, it said we ended up with a chloride salt. So what's happening here then? So HCl is an acid, the clue's in the name, hydrochloric acid. Ammonia, as the nitrogen has a lone pair, is a base. Well, what do acids and bases do? They react together. So the first molecule of ammonia will attach onto this carbon to end up as an amide, and that will produce HCl. A second molecule of ammonia then reacts with the HCl, and it basically gives you NH4Cl. So that's your chloride salt, ammonium chloride. So this would be the equation for the second part of the question.